Today we're going to review graphing linear functions. Our first equation is in slope-intercept form. Here's my slope and there's my y-intercept. Now remember, when you start graphing, you want to start with your y-intercept. So I'm going to go to 3 on the y-axis, and I'm going to put a point, and then I'm going to use my slope to get some more points on my line. Now remember, slope is defined as rise over run, so this is how many units I will rise, and this is how many units I will run. So I'm going to rise 1, and I'm going to run 2. Now we only need 2 points to draw a line, but when I graph in slope-intercept form, I like to use at least 3. So I'm going to do that again. I'm going to rise 1, and I'm going to run 2. And just remember, the more points you use, the straighter your line's going to be. Now I've got my 3 points, and I'm going to draw a line to connect them. Remember, it is a line, and so I like to see arrows on the end of that line. Let's look at another example. Now this one is also in slope-intercept form, except my slope is a whole number. Again, I'm going to start with my y-intercept, which is at -3. And we said that slope is defined as rise over run. So I'm going to make that into a fraction, so I'll know how many units to rise and how many units to run. Now notice on this one we have a negative slope, and remember, a negative slope is falling on the right side. It's going downhill, I like to say. So I'm going to rise 4 units, and I'm going to run 1. And again, I like to use at least 3 or more points. So I'm going to run 4, or rise 4, excuse me, and run 1. Then I'm going to take a straight edge, and I'm going to connect those points. And there's my line. Now this one's a little bit different. You should notice that on this one, I don't have an x variable. So I'm going to plot 2 points, and it doesn't matter what my x coordinate is, my y coordinate must be, and make better parentheses, must be 6. So I'll plot a negative x coordinate and I'll plot a positive. So I'm going to plot -1, 6. And I'm going to plot +2, 6. And then I'm going to take my straight edge and I'm going to connect them. And you will notice that it is a horizontal line. Okay? If it's only one variable and the variable is y, it is a horizontal line. Let's look at another one. Okay, when I look at this example, it's different from our previous example. In this one we have x. So I'm going to do exactly the same thing I did in the previous example, except this time my x is going to be -3, and we don't care what the y coordinate is. I'm going to plot 2 points because remember, from geometry, I only need 2 points to make a line. So I'm going to plot -3, 4. And I'm going to plot -3, -2. And I'm going to take a straight edge and I'm going to draw my line. Okay. And let's look at one more example. Now this one's totally different from all our other examples. If you notice, this time, here's the equal sign, and my variables are on the same side. Okay, remember this equation is said to be in standard form. And when we graph in standard form, excuse me, we only need to use 2 points because we're going to use the x and y intercepts. And remember from class we talked about that the x-intercept is where the graph crosses the x-axis and the y-intercept is where the graph crosses the y-axis. Remember to find the x-intercept, y is 0, and to find the y-intercept, x is 0. So let's start with the x-intercept. I have 2x minus 3 times 0 equals 12. I have 2x equals 12, divide both sides by 2, and I have x equals 6. So I'm going to go plot the point 6, 0. So I go to the origin, I go over 6 units, and I go up 0 units. Next, I'm going to graph my y-intercept, but this time x is going to be 0. So I'm going to come over here, and I have 2 times 0 minus 3y equals 12. I have negative 3y equals 12. Divide both sides by negative 3. And y equals negative 4. So I'm going to plot the ordered pair 0, negative 4. And like we said previously, you only need 2 points to graph a line. I have my 2 points, and now I'm going to connect them with a straight edge. And there I've graphed an equation in standard form. Now we've looked at several examples. If you need any more help, go back and review those examples. See you in class.